Hello, everyone, and it's been a while actually. So, right now, we're going to continue our last discussion. Actually, no, not last discussion, but we're going to continue our last video. And here, this would be the next thing we're going to do. That will be to have a practice video about the introduction and the limit of a function. So, you know me, this is just true or false. Okay, this is to test your knowledge about it. Okay, basically to assess yourself. So let's go. Oh, whoa, 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 whoa. Wait for a second. All right. I assume that you have seen the statement. The statements rather. So I hope you should not cheat. You should not cheat. Okay. But anyway, let's just proceed anyway. This is just a practice video anyway. Let's go. Oh, wait. Limits are about finding the exact value of a function. Limits are about finding the exact value of a function, true or false. The answer is false. In limits, it's not about finding the exact value. No, rather it's about the estimate or what? Approximation. Okay, approximation in what? By getting closer. Okay, by getting closer. So no, not exact value. Next, or rather approaching value, basically. The limit of a function as x approaches 3 and the function, the same as the limits, with an input of 3 will have the same results. The limit of a function as x approaches 3 and the function, the same as the limits, with an input of 3 will have the same results. True or false? The answer here is false. Okay? It depends. Like, basically what it's trying to imply here is that the limit of f of x as x approaches 3 is just the same as the function of 3. Okay? Okay? So here, the limit of a function and the function, the same as the limits with an input of 3 will have the same results. Well, no, not at all. For example, if let's just say the function is a constant, like for example, the limit of 2 as x approaches 3, well, the answer is 2. I already discussed to that last time. If your function is 2, okay, so what would be the result if your input is 3? The answer is still 2. So that is correct. Okay. Another one. Let's just say your function is x. So what would be the result if the input is 3? So the answer is 3. Now what if we will get the limit of this one? So limit of x as x approaches 3. The answer is still 3. So yes, in these two conditions, yes. And maybe there are some other functions that will result the same thing to their limit version, but not all. So the answer for that is false. Okay, false. Not all will result on the same, will have the result of the same answer or the same value. Not all. Okay. Plus, it doesn't specify what type of function. If it's constant function, just like this, or a function of x, yeah. Or maybe there are other functions out there that will probably get the same results. But in other cases, no. So not all. They will not have the same results. It's like you're asking, is limit of a function and function the same? Or are they both the same? I mean, the answer is no. Okay, next. The representation of limits is the limit of f of x as x approaches a, or lim f of x to a. The representation of limits is this one. The answer is true. This is what? the correct way on how would you represent the limits. Okay? This is the correct representation of limits. All right? So this is actually in general. You get me? So yeah, this is true. Okay? Next. Suppose you have a constant function with an input of 0. If you're going to find the value of this function with an input of 0, but with the use of limits, then their answers are the same. Again, suppose you have a constant function with an input of 0. If you're going to find the value of this function with an input of 0, but with the use of limits, then their answers are the same. The answer is true. Okay? I already discussed that to you last time. Okay? If you have a function that is a constant function, okay, if you're going to have any inputs, let's just say 2, the answer would be the constant itself. The same thing goes for the limits. Okay? So if the constant, if the function here is a, what do you call this one? The function here is a constant and the input is 2 and you're asked to get the limit, the answer is still 2. So the same thing, if you substitute with 0, the answer is still the, oh, wait, I was wrong. Not 2, it's constant. So anyway, if you're going to use the input of 0, the answer is still the constant itself, just like this one. F of 3 is equal to 0. What will be the result? The answer is still 0. Okay? The limit of 0 as x approaches 3. The answer is still 0. So meaning both of them are the same. So in short, the value of the limit of a function with an input of 0 will have the same result as the constant function with an input of 0. Okay? They are just the same. Okay? I discussed that already though. Sorry if I kept bragging about it because how should I say this? That's like the previous video we discussed. You get me? But yeah. Suppose you have a function f of x is equal to x with an input of -1. If you're going to find the value of this function with an input of -1, but with the use of limits, then their answers are not the same. Suppose you have a function f of x is equal to x with an input. Oh wait. Anyways, yeah. With an input of -1, okay. If you're going to find the limit, to find the value of this function with an input of -1, but with the use of limits, then their answers are not the same. True or false? Well, the answer is false. The answer will be the same. Okay? So f of x is equal to x, right? So substitute -1 to the x, the answer is -1. So your f of x once again is what? It's x, right? So here, if you're going to get the limit here, the answer is still -1. It approaches to -1. And if you're going to find the exact value with, which means with the use of this, the answer is still -1. Okay, so therefore the answers are the same. Okay, they are actually the same. Okay, not false, not true. Rather, it's false. And lastly, in a nonlinear graph, we can exactly find the slope of a tangent line at any particular point of the graph. Again, in a nonlinear graph, we can exactly find the slope of a tangent line at any particular point of the graph. The answer is no, it's false. You cannot exactly find the slope of a tangent line. No, not exactly. Because if it's exactly, you know what will be the result? Okay, remember that the slope is what? Delta y all over delta x. Or in other words, y sub 2 minus y sub 1 all over x sub 2 minus x sub 1, which is, if you're going to find the slope of a tangent line exactly, you will have 0 all over 0. So, no. Okay? No. All right? You cannot. Okay? It's not possible. But by approximate, yes. But exactly, no. By estimate, approximation, yeah, but exactly, no, because this would be the result. Why? Because you see, if you're going to find the slope of a tangent line, you need 2 points. Okay? But you see, we're finding a slope of a tangent line at any particular point of the graph. Okay? So for example, this is the graph. And then here is your tangent line. Okay? That is your tangent line. All right? Imagine this is a perfect tangent line. Okay, wait, let me fix that. So what happens here is that your 2 points would be the same. Okay, so here you will have point A and point B the same. So if they're the same, then their coordinates will be the same as well. So the result would be 0 all over 0. But by approximation, like for example, at this view, it may seem that they overlap. That means they have the same position, yes. But when we zoom in, okay, they're not that actually. How should I say this? They don't actually. What's the best way to describe it? They don't actually overlap. Okay, it's just that at the outside view, they are, yeah, let's just say, again, in the outside view, they are at one point, but when we zoom in, they're like this close. So yeah, we can get the slope of a tangent line, not exactly, but at least by estimate. So to answer that question, it's false. Okay? And that will be all. So we're going to have our second practice video soon.